Hey guys, so welcome back. In this video, we'll be trying to solve the problem shortest common subsequence. That is the problem of the day on Geeks for Geeks on 11th November. Alright. Now given two strings S1 and S2, find the length of the smallest string which has both S1 and S2 as its subsequences. Alright. So here we have S1 as geek and S2 as EKE. Now if you see this EK of EKE, it already comes inside geek. Right. So how many extra characters do you have to add? You just have to add this last E at the end, right? Then the answer string we have will contain both S1 and S2. So your output should be 5 because the length of the answer string will be 5, right? So now let's see as to how we can solve this. All right. The best way to solve this problem is by using a dynamic programming approach. All right. So we'll be basically storing the number of items in S2 or like the smallest string as your columns and the number of elements in S1 as a rows. Okay, so in S2 we have 3 items, so we'll be having a DP starting from 0, 1, 2, 3. All right. In S1 we have 4 items, so we'll be having 0, 1, 2, 3, 4. Now if you're wondering as to why we start from 0, it's because every DP needs a base case, right? So the base case will just be initializing everything to be 0 in the beginning. All right, hopefully this makes sense. Okay, now let's move on. Okay, now let's move on. Now we'll be checking for each character, like if they are the same as the other one or not. So first we'll be checking for G and E. Are they same? No. So we can directly put 0. Now one thing you guys have to note is that if the characters are not same, we have to add 0 for the current position we are at. Apart from that, we also have to add the maximum of these two numbers right here because they represent the maximum common subsequence we have right before our current element. All right. So just keep that in mind. And apart from that, if you find out the current character to be same, right, we have to add um, this particular value, like I minus 1, j minus 1 value into our answer as well. So I'll be like explaining as we go by. All right. So for now, we'll just put 0 over here. Okay. Now we'll compare G and K. G and K is also like it does not match. So we'll put 0. Okay. And these elements are like anyway 0. Then G and E again 0. These elements are 0. Okay. Now let's move forward. We'll be comparing E with E. All right. E and E, they match. So we'll be putting 1. 1 plus the I minus 1, j minus 1 number, which is 0 for us right now. So we'll just put 1 here. Now compare E and K. Are they same? No, they are not same. So what will we do? They are not same. So we put 0 plus the maximum of these two values, which represent the subarrays or like the common subsequence we have up till now. So it's 1, right? So the answer will be 0 plus 1, right? So the answer is going to be 1, right? So you can just rub this and put 1 so it looks nice. All right, now we'll move forward. Check E with your last E. They are same. Yes. Now since the characters are same, we'll put 1 plus this diagonal element we have, it is 0. So we'll leave it as such. Okay. Similarly, we can fill the rest of the rows. Compare E with E, right? It is same. So we can put 1. E with K, 1 plus 1. Your answer will come 2 over here if I'm not wrong, right? You have E here, you have K here. They are not same. Sorry, it will be like 1 itself. They are not same plus the maximum value of these two elements, which is 1. So you just have 1 as the answer. All right. Next element, E with E, ending. Here you'll get the answer as 2. And you know why? Because E and E, they match, so you have 1 for that, plus this element right here. Right? So 1 plus 1, answer is 2. Right? As simple as that. So let's move forward. We have K, right? K with E, it does not match. But we have this element right here, so it becomes 1. I'll just put this in LO itself, so it's uniform. Then we'll compare K with K, they match. We'll have 2 here. Then K with E, they don't match, right? So you'll have 0 plus the maximum of these two elements, which is 2. So we can just remove the 0 and put it as 2, right? This is what your answer will be. Now at the end, you have to just return this thing, right? This is the common elements or the length of the longest common subsequence that you have with you. So what should your answer be? Your answer should be m plus n, which is the length of these two strings, minus this thing, right? Minus the common subsequence we have. That's what your answer will be. Like that's how you solve this problem. Let's see as to how we can code this out. Okay, let's try and code this out. We'll put m as equal to the len of s1 and n will be the len of s2. All right. Now to make our dp table, so dp0 into n plus 1 because we need the zeroth row in the beginning. So range, sorry, here we should not have I, we are putting the blank for that. For range m plus 1. All right. Now we'll have two loops to go through every single element. So for I in range 1 to m plus 1 and for j in range 1 to n plus 1. All right. Now inside of this, if s1 of I minus 1, right, is equal to s2 of j minus 1. If the characters are same, then what do we do? Then we can just say dp of ij, right? dp of ij will be equal to 1 plus dp of I minus 1, j minus 1, right? Else, we can directly do dp of ij will be equal to the max of dp of I j minus 1 or dp of I minus 1 j. All right, that's basically it. Now at the end, we can just return m plus n minus dp of m. Sorry, yeah. So let's see if this works. Okay, let's see. Okay, let's see now. Okay, should be dp here. All right, few bucks. Okay, it works. Let's submit. So that's how you solve this problem. If you have any doubts, do let me know down below. And that's it for this video. See you in the next one. Goodbye.